Quantum computing is an exciting field of study that holds the promise to revolutionize the way we solve complex problems. Unlike traditional computers that rely on bits to store and process information, quantum computers use quantum bits, or qubits, which can exist in multiple states simultaneously thanks to a phenomenon called superposition. This ability to exist in multiple states at once gives quantum computers an incredible advantage over classical computers in certain applications. It allows them to perform many calculations in parallel, vastly increasing their processing power and potentially tackling problems that are currently considered infeasible for classical computers. The concept of quantum computing can be a bit mind-boggling, but let's break it down. Imagine a traditional computer as a room with a series of bookshelves, each shelf holding a bit that represents either a 0 or a 1. This binary system forms the basis of classical computing. You can manipulate these individual bits to perform calculations and solve problems. Now, picture a quantum computer as a room filled with qubits. These qubits, represented by subatomic particles like electrons or atoms, can be in a state of 0, 1, or both 0 and 1 simultaneously. This is the essence of quantum superposition. It means that a qubit can hold more information and perform more calculations than a classical bit. But what really sets quantum computers apart is their ability to take advantage of another quantum phenomenon called entanglement. Entanglement is like a special connection between certain qubits, where the state of one qubit is instantly affected by the state of another, no matter how far apart they are. It's as if they share some sort of invisible link. This entanglement property allows quantum computers to solve certain problems incredibly quickly. For example, factoring large numbers into their prime factors, which is at the heart of many encryption systems, is a task that would take classical computers an incredibly long time. However, quantum computers could potentially solve it in a fraction of the time by utilizing their parallel processing power and exploiting the quantum nature of the problem. Moreover, quantum computers have the potential to revolutionize fields like drug discovery, optimization, and artificial intelligence. For example, they could help us understand complex biological systems and simulate the behavior of molecules with unprecedented accuracy, leading to the development of new drugs and treatments. They could also help optimize logistics and supply chains, solve optimization problems in finance, and improve machine learning algorithms. While the potential of quantum computing is immense, there are many challenges that need to be overcome before we can fully tap into its power. One of the main challenges is building stable and reliable qubits. Qubits are incredibly fragile and prone to errors, which can destroy the quantum information they carry. Researchers are actively exploring different technologies, such as superconducting circuits, trapped ions, and topological qubits, to create more robust qubits and improve their error rates. Another challenge is scaling up the number of qubits. Currently, quantum computers have a limited number of qubits, usually in the range of tens to hundreds. To solve really complex problems, we need thousands or even millions of qubits. Scientists are working on developing techniques to overcome the technical hurdles in scaling up quantum computers while maintaining their coherence and preventing unwanted interactions between qubits. Despite these challenges, progress in quantum computing is being made at a rapid pace. Major companies like IBM, Google, and Microsoft, as well as leading research institutions, are investing heavily in this area. They are constantly pushing the boundaries of what is possible and engaging in a collaborative effort to make quantum computers more powerful, reliable, and accessible. In conclusion, quantum computing represents an exciting frontier in the world of technology. Its unique ability to leverage quantum superposition and entanglement holds immense potential for solving problems that are currently beyond the reach of classical computers. While there are still many hurdles to overcome, the progress being made in the field is promising, and we can look forward to a future where quantum computers play a vital role in advancing scientific research, solving complex problems, and shaping the world we live in.